I believe we're back. Yes, the stream died, but it's back, and I'm a little bit sniffly. I need to mute myself a bit when I blow my nose. Okay. So, right, so NDX inverse is an array, but NDX is a map, so I need to, I'm not knocking onto that. What am I doing? I'm inserting, I believe. Insert KV, yeah, so insert at key timestamp, so no, at key author, right? A key replica, yeah. So replica is R, right? I think. No. R is what is R? Oh, hold on. It's log of Chronofold NDX. Yeah, so Chronofold NDX env and ref, and op is tref file. So I think I have the, well, T actually therefore is timestamp replica index and replica. Not super clear about stuff right here. My op has timestamp 1 alpha in there. 1 alpha. So yeah, no, that makes sense. So I'm inserting with key R, the author, or the replica, and an array index in there. Right, so actually I do need to I need to destructure my my map here. How do I destructure my map? Well, okay, I need to think about this for a second. N is a map. Trina is empty, which why not? And we receive an op for a particular author. So we know that we're interested right away with the array well, let's call it R for now. I think it's probably a better name for that. But the array that is a lookup, which is going to be a maybe, in fact. So, and yeah, a default value will be empty array, and the function is the function is id, I think, for now, and then the value is lookup, which would be given a key and a map, and the key that we're interested in is that we received this op for replica R, so we're interested in that, and we want to look that up in our indexed map. Okay, I think that will be easier to understand if I do this. Maybe ndxm. Okay, and ndxi is not a map. That's here. Let's call it ndxinv. And this really should be ref, and this should be replica. Otherwise, I'm not going to be. And replica index. And really, this is auth and a and dx in the paper. But yeah, maybe I should have kept that. Don't know. Well, you know what? Here, I can call it that. No, that's going to confuse me. Okay, what's going on there? Okay, so I get an array, which is really the sort of the array ndx. And yeah, and then based on what's inside there, I know that at replica index, so I think that means well, this array should be converting a timestamp. So a timestamp will be something like alpha, well, 1 alpha. And we're saying 1 alpha is in alpha's array, and tells us that at entry 1 at entry 1 we have alpha 1. Note that alpha 1 is at array index 1. So it doesn't need to link to an array. I'm mistaken here. It needs to link to an index, and we're good to go. It just may be better if it links a timestamp to an index, isn't it? Yeah, that's the better way. So then we look it up, and we look up. What do we look up? Well, we look up a timestamp now. So that's this guy. So I'm not even sure whether you need to. Well, let's say we name it T, and we look up this timestamp T in NDXM, and we get nothing. Also, we don't need to. Maybe that. Oh, so is it just? Do we get a? Do we map to a maybe index? I mean, having nothing is no. It's no. It's not. We don't need to map to a maybe index. So we just look up T, and maybe we just case over it. If we have something in there, it's an index. So what does this mean? It means that the op we try to insert already existed at that timestamp. That's an error, isn't it? So I think our representation is not the right one. But I'll continue with this for now. I think this probably shouldn't happen. I think there's a way to, is it unsafe perform crash? Unsafe through exception. Yeah, that's it. It takes an error. Didn't expect the timestamp to already exist. Okay. So why do we even look it up then? That's the. I mean, I guess right. Then maybe what we need to do is to react to an insert that. Oh well, I guess. Yeah, insert doesn't check whether the key already exists, it just replaces it. But isn't there an issue if we receive an op? Is there a way to check before? Well, I guess there's lookup and then insert. So maybe we start with checking and then, or is it update or delete? No, so not that. Size pop member. Well, test if the key is a member of the map. Maybe that'll be faster actually, rather than looking it up. So case member T NDX of true. Then we are unhappy, and then of false. Then we say, is that? No, I think it's. That's what we want. And then in this case, we insert T into NDXM, and then maybe we. So that's what. That's our new NDXM, right? So let's call this new ndxm and put it right there. But I think in the end, just inserting will probably do, but just want to see what happens when we send malformed ops as well. Okay, so then we snuck infinity to ndx invert, but that's not right either. That was, I'm thinking of next, not of and where did I put my next? I didn't put it in there. Okay, I was missing a key thing, which is next, but maybe, where do I have it? Yeah, I have it right after my Chronofold in there. Yeah, I think that makes sense. And you're not happy with that? I can't use this as a constructor. Why not? Should be able to use Unicode as a constructor. No, that's a little bit sad. Purescript, Unicode, constructor. Oh, they have to begin with uppercase, so yeah, of course not. Yeah, okay. Infinity is what you shall be called in this case. Oh, I guess we can do a... No, we can't do an alias, because this is not a type. Can we do aliases for type constructors? I mean, I guess I could do... yeah, I could maybe just do infinity is of type index and is equal to infinity. You're not happy with that? Purescript. Well, that's a little bit sad. And if it's not in types, no, doesn't want to. Okay, okay, fine, fine, fine. Don't do any fancy things. Infinity. And, right, so we can't match member is a bool, and so maybe, oh my god, so then maybe it was constructors, no. Unexpected token, oh maybe because of the indentation actually, right. And do we need an in there then? Yeah, probably we do. In. And then, yeah, these are value, not constructors, right? Yes. But we don't construct an error like this. How do we construct an error? String error with error. Lowercase error. And then we import it, right? String to effect unit, string to error, that guy. Okay, snock we also need from array. Okay. And so log, but then we said log also had next in there. So this would be next. And we need to care about next, new next or whatever. So next, what does next have? Oh, next is the thing that needs to snock infinity into. We need to snock infinity into, I believe. And then the new ndx, and then the ndx inverse. That is just an array, is that right? Yeah, an array of timestamp, such that I believe we we put the timestamp into ndxinv. How's this work already? Array. Oopsie. I think I just saved this page. Yes, array, fine. Purescript array. All right. I mean, I think it would be this, right? Right. Infix version of index. Purescript arrays. So that's to read and then to insert into a sorted array. No, we don't have a sorted array. Well, right, we might not have a sorted array. Insert at, creating a new array, returning nothing if the index is out of bounds. That's it. Okay, so ndxinv, and we do insert at, and so the index is the index of the chronofold. C. So it's kind of length of C, really. Yeah. Length of C. And the A is the timestamp, I believe, so T. And that takes care of ndxinv. And then we need to take care of ref, and ref is the causal parent, and so that's where we have a root, I believe, except we are the root at this point, so that's where we say nothing, in fact. So the op contains OR, which is the ref. But do we need to translate it to the local coordinate? I think we probably do. But for now, let's say that we don't even do the check. And so that's a map from replica. I mean, conceptually, it's a map from timestamp to timestamp. And now I decided to make it a map from replica to array of timestamp. I think that's a mistake. I think let's just make it a timestamp to timestamp for now. And therefore we don't have insert at imported. That's the one. And so we'll do the idiomatic thing here. And right, so and we would need to do some kind of check as well, I think. Let's say that. Let's say we do, just as we try and figure out how things work. So we check whether our ref, the OR, which is a maybe timestamp, That's really bad name then. If it's maybe times 10 to call it OR, why do I call it OR? Because it's the ops ref. Hmm. Right, in fact, if oref is nothing, so we do I think we do maybe with oref, and then if it's nothing, then do we insert anything into the ref data structure? I think we do, right? In the non-sparse case, we just say so maybe it's a maybe timestamp because of that root case here. And then what? We map timestamp to timestamp. I mean, I'm inserting the origin here, or the root, so I don't think I need to insert the origin. I think it needs to be, I think it's an invariant and it needs to be always there. So I'm wrong with the empty alpha log. Actually needs to have the origin or whatever in it. So let's call this root, and that means that we're in fact root is empty, is insert of insert, and the key would be we are at timestamp what? We're at timestamp alpha 1. Yeah, we're at timestamp alpha 1. So timestamp 1 alpha, and we insert nothing. And then we say that this guy starts with root. Oh, well, there's a root alpha. Okay, so we make root a function. We say root replica is this, and then we say root alpha here and root beta here. And then we know that ref has some stuff in it, and then when we receive oref from the op, then it maps t to oref, and that's it. Yeah, so we're just really only inserting t into oref. I mean, we could make a check, but right now let's just insert t into oref. Then this could be really insert t into ndxm as well. Okay, let's do what I said I would do, and let's do the same thing for ref. New ref, case member t ref, and through. Didn't expect the timestamps to already exist. Right. In ref, and here in ndx. And then we insert in ref, and we say that this is new ref, and then new ref, and then I think we see that we never use the inside of the timestamp, so we can just say that this is t. Okay, and then what? And then do we have errors? We do have errors. We have a timestamp that is not capitalized correctly. And then we're trying to snog V, but V doesn't exist anymore. No, it does exist. So what's up? Not match type, maybe with array. Snog is partial. Ah, okay, I see. It's snog CV. So we'll be snog next infinity here. You still not happy with that? Maybe value with value. Because V is a value, right? Oh no, I made it a maybe value. I think that was a mistake. All right, yes. What am I inserting? I'm inserting at t in ndx. I'm inserting, what am I inserting? In ndxm. I'm inserting just the, right, the current, the length, I think length c. And maybe I should call this current or something. I think that that's what the Rust implementation does. And it makes sense to me. Current local index, all right? And then we say, well, let's call it cur to just be what you're not happy with length of C. Array value is type string. Oh, what? Length? It's not length. Is it size? Size. No, it is a length, so I must have just imported the wrong one. Data array, maybe from data string. Yeah, so it's gonna be happy here for a sec, right? But that's fine. Length. Okay. Right. Yes. Here I inserted t. I'm actually I'm inserting cur here into ndxm. You could not match index with. That's right, because in fact we've made a new type of this. And then what? And then same thing. Oh no. Insert at length. Right, so in that case, it's actually the unwrapped. Index. So that's not very pretty, but it is what it is. So what's the problem? Could match maybe with type array. Is t. T is a timestamp. Let's look at insert that again. Oh, it returns a maybe array. Yeah. Okay. So new ndx inf case blah of. I mean, I could maybe, but this maybe is better. Just if it's just a, then a, and then what do we do if it doesn't? Right, creating an array or nothing if the index is out of bounds. Right, so we scream. That's what we do. index out of bounds. Index out of bounds in ndx end. No. Okay. And then we say this. Now new ref is of course missing its index, and I think that's cur here, right? Yeah. Okay. Except it's not. Ref could not match maybe timestamp with type index. Oh, right. Yes. No, absolutely not. That's not this. Yes, it's not. It's not cur. I'm inserting at t or ref. That's what I'm inserting. And then, yeah, I need to check that that t is a member of ref is not correct. Oh, member requires a node instance. Okay. Well, I think that's interesting. It's actually very interesting. But I mean, actually, does map requires an node instance? Actually, I think, in fact, I've been loading myself into a false sense of security there. Hey, thanks. Hey, I feel like I've been moving forward for some reason, right? After something is understood, then it becomes easier to program. Okay, and yeah, ord k. I mean, we have an ord instance on map if we have an ord instance on k, but yeah, I think it really implies we need an ord instance on k. Yes, I feel like I am. I feel like I'm finally doing some programming, you know, after 2 days of trying to understand the paper. But yeah, I guess that's where things are. And, next time I try to do something like that, it'll be faster. So ord instance on timestamps is something that's actually a little bit sort of or timestamp is a little bit tricky because it relates to the whole partial ordering on timestamps. And oh no, but I think we do have a total ordering because we just decide we have we can do ordering via replica first and then replica index. Yes. So no, it's all good actually. And am I in the right direction there? I think my timestamps are always alpha blah, not number blah. So it should be really replica and then replica index, I think. And in fact, maybe we just say that it's index. Or is a replica index? I mean, a replica index is a different thing than a replica. But I think I'm going to be annoyed by this wrapper here. So let's make it a type synonym. And that's going to change a few things in my code, but that's all good. We say rep 1 and alpha 1. And we don't introspect the timestamp here, so we're good. We just need this ordering, and so yeah, I think that's going to be maybe my first time writing an ord instance. So ord timestamp where is it compare, right? and we're comparing a timestamp rep I with a timestamp rep R1 and, well, okay, AI with a BJ. And I think there's a smart way to do this that I forget, by using an instance on ord, or an instance maybe on orderings, such that we can maybe, I think there's a monoid instance on orderings basically, I think. So in which case I should be able to do compare AB and append that with compare IJ. Or it could be compare IJ first, but I think that's the thing. And then I can't derive this, it's fine. And then I need compare from ord, it's fine. It's not happy. Oh, because you don't have a... Sure, but you can derive that though, right? You can derive the ord instance on replica from the new type, right? And then, oh, we need EQ. Yeah, forgot about that. EQ timestamp. Is that what we do? Oh no, we just need to write EQ. Hey, no, you can't derive this, right? Oh, instance EQ. So that's simple. EQ timestamp. EQ timestamp. Where is that? I forget what it is in Purescript. EQ timestamp AI timestamp BJ equals EQ AB and EQ IJ. Okay, sure. Yeah, we can derive EQ as well. Hey, seems happy with that. And yeah, so actually let's just check our instances, which means that we are, for the first time in a really long time, going to actually run code. That's an exciting moment. So let's compare timestamp replica 1 with timestamp replica, let's say 1 and 2 for now, and then let's log show that. And you're not happy with comp because it's compare, is that what it is? I think it might be, yes. And we have another error. We can comment that. We don't need to do what I just did though. What am I doing? Did I change the keyboard layout by mistake again? I did. Wonderful. We need to uninstall that keyboard layout. I'm going to do that right now. Keyboard settings, input language, I think. And there's no back button. Wonderful. Yes. Adding exit region. No. Okay, keyboard. Edit language and keyboard options. Okay, keyboard here, remove. Yay, that's good. And now I can comment out and have a nice yellow thing that tells me that I am on the right path. I just need to start a new terminal. Say it's Bago run. Whoa, why is this so hard to compute? Okay, because there's some other stuff that doesn't compile in my, in another library. So let's not import that other library if we can avoid it for now. I'm gonna need to import that, aren't I? Yeah, that's because of my. It's because of this. Okay, well, for now, let's say that it's not imported. How about that? Motor in action not found. That makes sense as well. And we can comment it and move this guy up there as well. And try again. Build succeeded. We like that. And wow, it's taking so littler. So yeah, so there's indeed an ordering. And this guy is littler than this guy, which is what we want. And then I believe we want this to be also littler. Yeah, so it compiles, and we can move on to here. But maybe I'll take a little break. What time is it? 7. Yeah, maybe I'll get some food on the way. So I'll be back in a couple minutes. And I'm back. So, what's up with this root beta? It's happy with the root alpha, but not with the root beta. No, it's not happy with the root alpha either. Okay, so timestamp. Right. I think now this is one. No, it is rep one. So we're trying to insert a key K map. Nothing. Yeah. And so, oh, it's maybe the alpha, there's the log data structure. Oh yeah, of course, it's the log data structure because we added the next array. So we need to pass the, as a second argument, well, we need to add this, right? Yeah. Except now you're unhappy with what's passed on the third, you need a map timestamp. So no, so I am, this is an array, this is an array, this is a map, and this is an array. Got it. So it's in this order. That's it. And then up. Right. So now that's correct because this up is actually, or conceptually it's really alpha 2. I mean, conceptually, or let's say to follow the example and the papers in this one base indices, then really up this is up to alpha, and we are passing it not a nothing but a p in it, except it might be a char rather than a string, right? Yeah, or a cut point, in fact. So we need to say to cut point and p. Is that not okay? Seems like I'm missing what I would want. Another value to cut point. Isn't it 2 cut points? Let's see. Cut point. Cut point from char. That's what we want. And p. And we need to have this imported. Oh, we do import cut points, I think. It should be fine. Oh no, we don't. So unless data string re-exports them. It does re-export them. So we should have it, but we don't. Because it doesn't re-export the one that we were interested in. Okay, so let's import it. Cut points, and it was what? Cut points from char. And you're still not happy because you can't match a cut point with a char, and that's all good. Here you go, have one. And now we don't have a show instance for logs, and that's all good. We can write one. We can't derive one, right? Maybe we want to do the generic, go the generic way right now. Yeah. Purescript, generic, deriving, show. Import all of these things. derive the generic instance. And get me the instance for log. Just log, not log of anything. And we don't need the constraint. And we need to, we have imported generic show. So what's up? We need show for index. Show for index. Ah, right. So that's actually a bit interesting. Ah, we can finally get our our infinity symbol. And then show anything else will be just show, wow, show I, and the class type index, right? What am I doing? Show our index. And what are we missing now? A show instance for timestamps. Right. So that's also, we can write that by hand. Show timestamp. Replica I and replica index. Replica R and I. And then we shall say that you will be well, you just be show of rep show R at show I. You know what? I'm going to do, I want some alphas and betas. So let's in fact just do something strange like this. Gamma show I and then R, then we can do show R and a separator. Hey, that compiles. Compiles and it just compiles actually, so let's just run it and just see. Module data, okay, I need to import the generics. This is generic rep, is it? I think, maybe. What's the name of the... I think it's not generics. Deprecated and and generics rep. Yeah, so spago install generics rep and run. Hey, so alpha 0 is this thing. Okay, let's pay a little bit of attention to what really we're seeing here. Right, so our log has, this is with the chronofold being empty, but it still has that sort of ref to the origin. Right, the tuple is because that's how the map is rendered. It's a generic instance for maps. And so it maps alpha1 to nothing. And alpha1 is sort of conceptually mapped to the nothing thing. And that's the ref, right? Yeah. The chronofold is empty at the beginning. Okay, and so then after we've appended one up, then the chronofold contains the value of the code point, so we're happy with that. The next array then holds infinity, which arguably you could say that it should have held, in fact, beforehand, that this guy is actually terminated by infinity. So indeed, that's the case. So let's fix that. And I think that means that this is the chronofold, this is the... so maybe we should write a empty log. I mean, yeah, we will do better than this with instances later, but for now, let's do this. It's an empty log, and that's actually going to take a replica. And then we have a replica. Yeah, we have a rep, and then that's going to be something a little bit like that, except it's going to be rep. And now we can say that this is an empty log for alpha. And this is an empty log for beta. And the root is this guy, so we can actually probably just inline it. Equational reasoning, bingo. And what I was saying was that we need infinity in here when we start. So if I do this, then what are you going to do, in fact? You're going to give me 2 infinities, but that's not what we want, right? Exactly. So great. So that's, we're recalculating this, and this is in fact new next. And new next definitely has some logic. New next, or new next. New next should be what? Well, new next is the relinking of the linked list, isn't it? So I think we check out is now infinity. So that's, yeah, that I'm thinking about the splicing that's going on there. That when we insert our first P, yeah, actually let's put it somewhere like here. That when we insert our first P, yes, I am using Streamlabs OBS, indeed. Okay, maybe we do this. You can use the gain function to add as an audio element to increase the mic volume. Oh, is my mic down again? I think that's just me, you know, moving around because I think that if I'm close enough, then it's good. But maybe I should have a compressor or an auto gain style setting in there. But that's, you know, that has its own problems. I'm in fact using an external mixing board with effects from that external mixing board on the microphone. So all of this, it already has a compressor and a noise gate. So if I add some kind of auto gain on the mic in OBS, I think all of this is not going to interact nicely. But no, what I can do is that I can remember that I need to be a little bit closer to the microphone, and then it will work nicely. Of course, that's relying on not making human errors, which doesn't happen. So let's put it in the log, shall we? Improve gain control in sound, and I need to think about that a bit. I've already made an improvement, in fact, something I did off stream, which is that I used to route desktop audio through the same channels I was routing my microphone in OBS, but now I have these things neatly separated, so that's a box that I checked a few days ago. Okay, so what are we saying here is that yeah, I mean it's fairly straightforward, and then in the sparse representation we don't even need any of that, but yet we're still going to write it, and I think that through inserting on the array, I mean I guess it's consing instead of snocking, and that's it. And that's OM, which, you know, is exactly what we expect. And if it was a sequence, then it'd be faster, but we don't even need a sequence because ultimately we're going to optimize this away. But I think making the naive version be a const actually makes sense. So I'm going to const And what am I consing? I'm consing the cur plus 1 is what I'm consing. So length c plus 1. And I think that, in fact, having done it this way is probably not the smartest. I think it's better to do, well, to do cur plus 1 here. And then to do, I think, that's the index, right? So that's index cur. And then here we can call it cur. And we haven't imported cons. This one. And what's wrong with infinity is that that's not what we're adding. We're actually, all right, this time we're consing to arrays afterwards, and that's in next, I believe. Okay, so that's also index. That's all good. And it compiles, and that's, I think, what we want indeed. That our next array now has 1 first. And because we, yeah, the indices there are now in proper 0 indexed array world. So, but I guess if we wanted, it might be confusing if I actually change, if I said I plus 1 here. It's really tempting though, but I think I won't do it. Okay. Okay, great. So we can do that, and so that should mean that now I can rely on this append op to do an append ops. That will take an array of ops. And how would that work? Were that just a fold over? That's just a fold, right? It's a fold of on append op onto the log with 2 code point array. I mean, that's actually oh no, with not 2 code point array at all, with ops, and actually, there we go, 0.3. No, not 0.3. Ops L. It's actually reversed here. It's fine. L ops in. Type checks. Good. And let's see. Let's do 3 alpha, which is at 3 and is I. And then let's now say that alpha log is append ops of up 3 alpha. And I think we have the array first now, which maybe just doesn't make sense. Maybe we, in fact, do it like that and then be 0.3 and be happy. Same name was used more than, yes, of course it was. And it compiles, and we have 2 code points, and we have 2,1 alpha, which is not what we want. So it's not cons. It's more like insert at something. I think insert at cur index cur +1, something like that. And this doesn't compile. Insert at int an a, and the next. Oh, maybe right. If we're out of bounds, okay, fine. Let's do this. Off. What? Okay. 1 to infinity. That's what we want. Okay, and so now we want an append string, which is what we were starting to do here, but nothing. It's fairly straightforward, really. Well, then log to alpha log. So I'm just going to how do I know the current state of the timestamp? Ops alpha equals no, let's just say alpha Pinsk equals append string alpha log Pinsk and and append string take the log in this string, and it needs to build an op. For this, I think it needs to introspect the log, but that's all cool, I think. It needs to know what its current sequencing is. And if it receives stuff from elsewhere, then that might not be immediately obvious. That's wrong. Oh, is it wrong? No, that's true. That is totally true. So we could keep a count for the local replica index in the log. Well, maybe there's an optimization further than that, but for now, let's do that. So the count will start at 1. And we will call that the replica index and put it in here. I mean, make it of type replica index. And then we'll make sure that we increment it here. I+1. Okay, let's check that things still compile and the test actually works. Up to alpha. Yep, you're happy with that, and you have the okay, cool. So that's cool, and in fact, I think I'm gonna keep this test here, and I'm just gonna say that alpha log is yeah, that we recreate an alpha log pins from the empty alpha log, and in fact, now these days we can call it, I mean, say empty log alpha. I think that's clearer. Okay, and now we do append string. And we have our I here and all the rest. BCD, let's call them. Right, replica index now. ABCD, ABCD, and we appending a string, yes. And so we two code point array S, that's perfect. And then we append ops, but we need to transform the ops and we need to transform the log as well by saying well, yeah, we need to do some let's expressions here. Say that this is cars or chars, and we're going to want to say I plus length chars here. In but also append ops is not right. We want to do something before append ops, which is kind of a build op, and so build op will take what? It will I think we can actually do this nicely with the anonymous function notation, maybe. I received the char, and so that would be the last thing in the op, right? Yeah. And so the current timestamp will be what? Is that the current timestamp? Yeah. So current timestamp will actually be maybe it would be better to have the timestamp in here, current timestamp. Probably yes. Yeah, probably yes. Okay, so not the replica index, but the timestamp, current timestamp. Let's document this here. Current timestamp. Okay, maybe we also document the rest. Be nice. And that's the thinned chronofold. And that's, well, yeah, that's the weave. And that's the causal tree. And the rest is kind of bookkeeping. We don't need to document that. I mean, you know, maybe we will at some point. And if it's a timestamp now, then this is timestamp rep 1. That's nice. And therefore here, if this is, so this is timestamp rep I, and we make sure that we do timestamp rep and the thing. And I think clearly we need to clarify things a bit here. I think it's okay if we do this. And so the question is now, again, how do we build our up? And our up starts with the timestamp. And so therefore, we're doing we're not doing append ups here, we're doing append up. That's one thing. And so as we traverse stack, the first element will be let's say P. So when we need a fold that gives us the array, what's it called? The index. What's that already? Must be in instances, no? I'm looking at strings now. Foldable must have some instance for this, right? Or is there some kind of fold thing? Modify it indices, take the foldable instance. fold rec, foldable, L, blah, not LM, intercalate, fold, find, LM, NEO. Purescript, fold array with index. I mean, I could do this manually, but rather not if I can avoid. But it looks like I will have to fold with index. What's foldable with index? So, and there's an array instance. There we go. Fold with index. Fold L with index. Is not in array then. I don't think. I think I need to install foldable traversable. And then I need to import something, don't I? Well, maybe it will find it by himself. Spago build I need to do, I think. And then fold L with index. Bingo. And it means that this function here takes 2 arguments, and if they're in the right order, we might even be able to do the anonymous trick. And they are in the right order. So timestamp rep blah and ref. Op needs a ref, which is a maybe timestamp. How do we do that thing? Ref. Well, ref is, especially when we insert a local thing, then it's always sort of the previous thing. And this we could say is 0. That's the better way. So, okay, so if I insert, how did I deal with this over there? Oh, well, I wasn't dealing with it. I said nothing for ref here? That's wrong. Yeah, that's totally wrong. Ref was, oh, food. Yes, my food delivery just arrived, so that's a little break, and I'll probably continue maybe 10 minutes more to get to the hour, and then disconnect until tomorrow. I'll be back in a minute or so. All right, and I'm back, and yeah, 10 more minutes. I think we can still move things a little bit forward here. So we have a just here, a just timestamp of alpha 2, in fact. That's what we have here. So let's actually even test this first. Alpha log 2 alpha log. Yeah, no, we don't need to. Yeah, we don't need to display this. It's all good. Yeah, build is fine, but run is better. And what? It's actually compile. Right, because I made this a timestamp now. Timestamp of that's our local log. So unfortunately, I think I need to destructure this, but maybe that's fine. Arabica index R and +1. Happy with that. Good. And right, because I didn't pay attention to the ref, and the ref is where it's at the end, isn't it? Yeah, ref is at the end, and so it's that map. It maps. Remove this. Alpha 1 to nothing, alpha 2 to nothing. Hey, welcome back. Alpha 3 to alpha 2. Okay, so that makes sense. It's just that I'm probably not appending things correctly. Then my new ref might not be correct. Up to alpha. So let's do this step by step. Alpha log 1 only appends to alpha. Up to alpha array up with op. Oh, yes, sure, why not? I mean, let's test all the little bits. And we want to then show alpha log 1. And let's do it. So we first have alpha 1 nothing, and then we have alpha 2 nothing. And that's not okay. And let's see. So I'm inserting T, which is the incoming timestamp. What do I want? I have alpha 1 nothing, that's good. I want alpha 2 alpha 1. So I need to insert. Oh, wait, that's where I need to do the translation. I think that's exactly when I need to do the translation. I don't know why it works here though. But I think I need to get the. Oh, how does this work? I'm receiving a remote ref, like, well, it's not remote in this case, but I'm receiving alpha 2, right? In this case, I'm receiving up 2. So really this should be 2, 3, just to make things more consistent. Alpha log 2 received up to alpha. Oh, right, no, okay, that's just that simply, I didn't pass it a ref, but I need to pass it a ref. Yeah. That's it. Cool, so that works, right? Alpha 1 nothing, Alpha 2 just Alpha 1, and Alpha 3 just Alpha 2. Yeah, it works. So I actually didn't need to do what? What did I do? No, I do nothing. I just added some parentheses there. And now I'm back into the appending the string business. And what? An anonymous function appears in invalid context. Okay, fine. This didn't work, but it's all good. It could be that I'm just not composing things correctly as well. But let's call this build up for now. And let's create a build up. Which will be our thing. And a build up will take a what? Well, take a I and then a val, I believe, right? Yeah. And it will return a j, and return a j plus I with its val in it. Isn't that it? What's that? Append string data construction main dot log was given 5 increment backspace is 6. Yes. So E and E could not match a value D, yeah. Build up. I could not match maybe 2 timestamp value to op. Which type log? Yes. Blah to blah to blah. I need to pass the B as well. Which is what? B is the accumulator. So let's call it ACK. And what we do with the accumulator here? Fold with index. We're supposed to return a B. Yeah, that's it. That's the B. Oopsie. What did I do? So we return B. And where do we put the op in the B? Well, we append it. So we append the op blah. No, actually we need to do this in the other order. We append to the log the op. And then we just fold that with index, build up of S. And my okay, cannot match value to op with op. Dip, oh, right, yeah. No, hold on. This parenthesis is this, and this is this. So What's the problem? Oh, op needs a ref. Yeah, of course. Op needs a ref, and the ref is what? Yeah, the ref is what we were thinking about right now, and that's why we needed a timestamp. And so I just need to know where the op. Yeah, it's here, and so it's a just of well, when we do it locally, it's really this. But I suspect that when we do it, I mean, it's this -1, isn't it? When we do it locally. Gonna mesh type log with value. Right, it's ACK. Whoopsie. And we append up. Yeah, I can't do that. I need to modify it each time. So that's, I need to pass it like this. But then a B, I pass it this function, a B, which is my current log. So that's, I can call this L, I think. And my FA. And then here I can just do I+1, I think, because I'm going to do it for each character. And I need to do this, I think. And then probably the same here. Why you? S is this. Oh, S is the string, right? So no, it's it's chars, of course. Yes. Gonna match code point with value. Oh, so maybe I do receive the val, and then I do wrap it in a value in the op. Woohoo! Compiles. Oh yeah, I like this. And then let's log alpha log insk log show. Would this be one of the famous cases where statically typed purely functional programming compiles and works? Thanks, one. I will absolutely oh wow, I get a runtime error. Beautiful. What's the runtime error? Didn't expect the timestamp to already exist in ref. That's one of ours. That's one of our errors. Okay, well that's a perfect time to stop, because things run, but we're catching some error there because apparently we're inserting a ref, probably inserting the ref in the wrong order, I would say. Because this is not all obvious what we're doing here. And it could be that, you know, maybe this is +1. Can't stop, huh? +1, and this is this. Yes. Yes, it was. And so now we have log alpha 11 with all these code points in it, Pinsk, and this 1, 2, 3, 4, 5 infinity for next. That looks fine. So that looks pretty weird. Yeah, that's not that. I don't think that's correct at all. But that's all. That's cool, and that's also probably not correct. And then what do we have? Alpha 1, nothing. Alpha 2, alpha 1, alpha 5, alpha 4, alpha 7, alpha 8. Yeah, so it's just that this J there, I think, is it's just a bit strange. Maybe I don't need to add. Maybe it's just J +1 and J. I don't need to add I here. Or maybe just I +1 and I. Could it be that? Let's try this. Alpha 1, alpha 2, alpha 1, alpha 4, alpha 3. So no, so we need to, I think, reindex this like that. And then it fails. Okay, so it's, yeah, it's just offsets in the arrays that need to be checked, but I think we're definitely on the right track. This seems like a productive stream. And yeah, I'm signing off for today, and nice to see you again, and see you tomorrow, probably around the same time, for more Purescript Chronofold adventures. Bye bye.